Hello and welcome to this video on brewing and what is significant other than oxygen when aging your home brew. Oxygen is important for cellular respiration at the very start of fermentation. This is how you make both energy and make more yeast cells. That leads to the consumption of oxygen and more yeast to undergo anaerobic fermentation. If there is still oxygen present at the end, it can cause problems for beer especially, but other beverages too. Oxygen is important for reactions. Oxidation is one of the most common ways to break chemical bonds. Despite this, oxygen is one of the better understood, but by no means universally or extensively understood, things in aging. It's why we need to look at other things that may not be as immediately obvious to you. Sulphites are the first thing, and there's two categories, the broader sulphites themselves, which we'll describe, and specifically underneath that, we'll talk about sodium metabisulphite. There is generally some kind of sulphites in every kind of wine that is produced. For that matter, it's also present in beer, cider, and similar. This is because of how the raw ingredients you're using are processed and what they produce, what is fermented, and what's used in other reactions. Because of this, you should expect to find at least 20 to 30 parts per million of sodium metabisulphite. That is nearly halved in the terms of free floating sulfite material. Once the beer, wine, or other container is opened, it does begin to gas off to some extent, so that number gets reduced even further. This is a big reason why sulfites, as a broad category, are very important. Sodium metabisulphite specifically, and this is as distinct from potassium metabisulphite, so do bear that in mind if you're thinking about it, is that it scavenges oxygen, and that is, it holds onto oxygen and pulls it out of solution and renders it relatively inert. This is not so helpful during the early stages of fermentation, as yeast will be able to use this oxygen and thereby allow you to get a more efficient fermentation. But later on, especially when we're talking about storage and aging, it is very useful. It reduces those chemical reactions that oxygen is involved in and means that you have a more stable end result. Another is ascorbic acid, and you may know this by the more common name vitamin C. This is another useful product because it, again, interacts with oxygen, mostly dissolved oxygen, and by doing so it releases hydrogen peroxide. By having both sodium metabisulphite and ascorbic acid, you wind up with a situation in which very little of the oxygen remains dissolved in solution. It is scavenged by one or the other. You need approximately 100 milligrams of ascorbic acid in each litre to completely react with all dissolved oxygen. You'll need approximately 62 milligrams per litre of sulfur dioxide to completely react out, and this is how you remove most of the oxygen. Having both of these is likely to result in a very notable change if you use the entire amount. Plus, you will be removing most of the oxygen, so you will be depriving your aging process of that particular chemical. Another will be a throwback to the very early part of making beer, and that is the type of beer that you're making. There are particular beers that are intended to be aged, and historically or culturally they've been made that way. They're often very complex, and often they have a very low pH, because they're intended to not only be stable, let's say, for a long time while they age, but it also imparts that notable flavour. These are often called lambic beers. Lambic beers use wild yeast and something like, say, lactobacillus that produces that particular flavour, but it's generally a combination of a microbe other than yeast and, well, rather obviously yeast. These are long-made beers, and when they're being aged, they're often done so in oak barrels, and generally for at least 1, 2, sometimes even more years. The big features here are that it's not a pure yeast strain being used, that it does have a lower pH and so is more acidic, which helps with its let's say, preservation qualities, and that it is aged for a very long time because of this. Beer itself, especially if you're aging it, is something that is complex. There's a lot of chemical reactions undergoing constantly in the large fermenter, the barrel, or whatever else you're using to store it. Things are broken down, things are built up, there are new reactions, new flavors, and more, constantly being generated. This is one reason why you can be doing this in a bottle. One challenge you will face, especially if you bottle condition your beer and then age it, is that the yeast will remain alive, and if there is yeast alive and active in your aging beer, they will begin to make more and often new flavors. If not while they're alive, certainly after death. The destruction of a yeast cell leads to a, let's say, umami-like flavor. This is sometimes called a protein-like flavor, and compared to meat or soy sauce. In other cases, it can produce things like a hazelnut-like smell, and depending on what it is, this can be desirable. So with beer, not so much. However, certain champagnes are considered desirable because they have this. And so knowing something about what your yeast does, especially after it dies, can be very helpful for aging. The death of these yeast cells can have another effect, and that's not related to the flavor. Rather, it's enzymes. Yeast is full of enzymes, and these are responsible for all kinds of things. Largely, it's the breakdown of carbohydrates and proteins, and in some cases, building them up. But in order for those enzymes to work, the cell needs to be intact and functioning. Since the cells are broken, only those enzymes responsible for destruction are still present and able to do their job. The result of this is that, first of all, because enzymes are constantly being active, you can find that proteins and carbohydrates still present in the beer can be broken down, which can alter their body and flavor. Another is that sedimentation can occur at the bottom of a bottle or other large storage device. In order to ensure that the enzymes and everything else they're doing aren't going to cause this, for example, something like protein haze, you should try and store bottles upright for at least a day, and ideally more than that, before you open them. The environment in which you store your aged fermentation is another factor. Traditionally, it has been kept in a cellar, and so cellar temperature has become a colloquial term for this. It's somewhere either just below or just above 10 degrees Celsius, or somewhere between 45 and 55 degrees Fahrenheit. If you go any colder, for example towards the temperature in a fridge, you'll find that the aging is slowed down because the chemical reactions, the yeast, and other necessary processes can't happen. If you go any hotter than this, you tend to find that things begin to react more and unpredictably. You also find that the yeast begins to become more active once more if it is still alive. In the latter case of too warm, you get unpleasant flavors. In the former case, you find that the aging is slowed down significantly and it is not to any particular benefit. Modern bottling processes have also added a particular benefit if you bottle your own beer or wine. You can store it upright. Historically, wine bottles have been stored on their side to prevent the cork from drying out and shrinking. Cork is used in very few wine bottles anymore, and if you're using something like a swing top bottle or a crown cap bottle, you don't need to worry about this. You can store all of your bottles upright. This means that you don't need to worry about it. Another option is to seal the bottle if you're using a straight cork rather than a champagne-style cork with something like wax. This prevents moisture from escaping, and therefore the cork can't shrink and you don't lose your seal. Going back to the contents of the bottle, and notably flavors. Thinking about beer in particular with this, malt proteins in beer will fall out of suspension, and this means that you get a change in the body of the beer over time, generally for the worse. Losing the malt proteins leads to a very thin body and often a very dry beer. Depending on what grains are being used for your beer, you will find that this has a greater or lesser effect. For example, wheat has more proteins that will more readily fall out of suspension, and so it tends to be more difficult to age. Comparatively, most beers that are expected to be lagered or otherwise stored in a cellar for extended periods of time rely on grains that have a better retention capacity or quality when it comes to those proteins. This means that your malt proteins don't fall out of suspension and you get a better body in the long term. Long-term storage is a big factor, but it's also preservation. Other than flavour, you want to make sure that anything you're keeping in a bottle for a long time doesn't turn bad. The last thing you want is to go to open your prized 10-year-old bottle of beer and find that it has turned to vinegar. One of the big ways this has been done historically is the use of hops. Hops kept beer, let's say, sanitary for long trips over international waters. This is great if you're going to be consuming them in a relatively short time, for example, about a year. Once you start going beyond that point, and possibly even earlier, you will find that the flavour imparted by the hops begins to fade, and especially if you're making a beer that has heavy emphasis on hops, you'll find that it loses this, and obviously that's going to throw your entire flavour profile out the window and you'll have to start from scratch. One thing you can do to, let's say, substitute for this keeping effect of hops is to brew a higher alcohol beer. Now, we're not talking anything ridiculous like Armageddon. You don't need a 40% or stronger beer. We're talking still reasonably modest levels of alcohol, between 7 and 9%. This is the sweet range where it's enough alcohol to help preserve it and to keep the flavours how they should be, but not so high as to, first of all, put you on your ass, but more importantly, not so high as to interfere with the actual flavour of the beer. High alcohol beers already tend to have a more complex flavour profile, which is helped by the fact that they keep due to that high alcohol content. This means that you aren't going to be losing anything from making it with a stronger alcohol by volume measure. If you're using a more traditional recipe that relies on something like, say, lactobacillus, this can help as well. The higher alcohol by volume measure ensures that only the desirable microbes coexist with the yeast for a certain time after bottling. This means that only those microbes you want will be involved with the development of flavors as it ages. Another consideration is how to prevent any of these reactions from occurring to an extent. And the easiest approach, let's say, in that it's most direct and simple in basic ideas, is the use of carbon dioxide, or CO2. CO2 can be used to prevent gases from filling in the bottle in the free space available. It is often a heavier gas than just about everything else that will be getting into the bottle, so it will always sink to the bottom in terms of the gases in there, and it will mean that it will force everything else out. Because of this, CO2 can be great for purging containers and ensuring everything that you're filling is only filled with the liquid that you want, or a relatively inert gas. When we talk about kegging, this can be particularly useful. If the keg is filled with CO2, or at least enough so that once you begin filling from the bottom up, the keg only has CO2 at the very top and no other gases are available. If you are bottling, it's one way to ensure that there is no oxygen in the bottle itself, and so if you are adding something like priming sugar to it, you only get exactly that amount of a reaction. There's no more to be had. There are other ways CO2 can be used as well, but these are perhaps the big ones in terms of aging. It is one way to stop anything from happening, and to ensure that there is no oxygen available for a reaction. As you can see, there is a lot going on in aging of your home brew, or any fermentation for that matter, other than what oxygen has to do. Oxygen is a complex field all of its own, and we will make a video on its role in aging eventually. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.